Hello students, welcome to All Force e-learning channel. This is K. Nageshwarov, your physics faculty. Today we are about to deal with session number 41, first year Neet. Okay, so in the last session we have discussed about motion under gravity related second application. If a body is projected vertically in the upward direction, whatever details we can explore, we have explored. And today I am going to pick up one more such kind of model, but in a different aspect I am going to explore the situation. See here, the situation is from the ground one body is projected in the upward direction with some velocity u. It has gone to certain height and it is falling back. Let us say there is a point here P. What is that point? P. From the starting point, this is the starting point. Let us take this O as starting point. With what initial velocity it is projected? Let it be u. From this starting point to reach up to this point P, which is at a height equal to h. At what height this point P is present? At a height equal to h. The time taken by the body to reach this point P, I'll take it as t1 seconds. How much is the time taken? t1 seconds. Starting from O to P, how much time it has taken? t1 seconds. And it is not stopping here at point P. It is going up and it has reached the maximum height, and then again it started falling back. And by the time it comes back to this point P, let us say the time taken is t2. Starting from this O. So for the body to travel from point O to P, how much time is taken? t1 seconds. For the body to travel from point O to along this path and to come back to P again, how much time is taken? t2 seconds. I hope you are able to understand. This t2 seconds of time is not the time taken from this point to this point. This t2 seconds of time is the time taken by the body to travel from O to and to reach maximum height and to come back to P again. Okay, right. Corresponding to t1 seconds of journey, what is the displacement? Displacement is h only, isn't it? t1 seconds of journey, it means it has traveled from O to P. How much is the displacement? H. Corresponding to t2 seconds of journey, t2 seconds of journey in the sense along this path, starting from O, it has gone up to here and it has come back to point P again. Okay, during return journey, it has come back to point P. Corresponding to this t2 seconds of journey also, what is the displacement? Again it is h only. Again it is h only. Okay, so let me try one general equation. This h, it can be expressed as, since s is equal to ut minus half gt square. Since you are dealing with upward projection, you will have minus half gt square. Acceleration will be replaced with minus g. I am going to write this h as, for this upward motion, ut minus half gt square. See children, in this equation I haven't taken either t1 or t2. I have taken only t. Let me solve this equation. Okay, what I am going to get, let us see, because here for this h, displacement corresponding to this t1 seconds of time, corresponding to this t2 seconds of time, what is the displacement? H only. So t1 and t2 might be there here only. When I solve this equation, probably I will be getting two equations for time. Let us see whether we will be able to get or not. Let me simplify this one. You will get 2h is equal to 2ut minus gt square. Let me shuffle this equation. Gt square minus 2ut plus 2h equal to 0. Isn't it? This is how you can modify the equation. Now see this equation, this is quadratic equation in t. Ax square plus bx plus c. Isn't it? So if quadratic equation, if you are having quadratic equation, you know how to solve the equation. Here possible roots can be written as minus b plus or minus root under b square minus 4ac by 2a. Here in place of minus b, what do we have? Minus 2u is there. So what you can write, 2u, isn't it? Plus or minus under root b square, 2u square, 4u square minus 4ac. In place of a, what do we have? G. In place of c, what do we have? 2h. 4 into 2, 8 g h. Okay, divided by 2a. Here is what? Z. Okay, so now let us simplify this further a little bit more. Here itself I can do, from this root I can take out 4 common. If a 4 comes out of the root, it becomes 2, and here you will have 1 2, and that 2 is, if it is taken out, and that whatever 2 comes out, that 2 and this 2, both numerator 2 and denominator 2, both 2 gets cancelled, and finally what you will have, u plus or minus under root this 4, it has come out, u square From 8, 4 has come out. You are left with 2 GH divided by 2 got cancelled. Here 1 2 is there, that 2 and this 2, and this 2. All are getting cancelled. So finally, what you are left with in the denominator, G. So this is what the possible roots. These are possible roots for T. Let me write it separately. Let T1 is equal to U minus under root U square minus 2GH by G, and T2 is equal to U plus under root U square minus 2GH by G. So that's how you can identify the roots. Now here let me explain this. I have chosen T1 as U minus. Yeah, intentionally it is chosen like this. You cannot call this as T1. Here what is T1? Time taken for the body to reach from point O to P. Compared to T2, T1 will be less, isn't it? T2 is what? Time taken for this entire journey. T1 is time taken for this journey only. So obviously T1 will be smaller than T2. So if that is the situation, see, wherever you have minus sign, that particular term should be attributed to T1, and T2 will be what? It's large when compared to T1. Okay, so this is the situation. Now, so we are having two roots. Okay, so let me make use of these two roots to explore a few points connected with this situation. I'll take product of roots. Considering product of roots, that is T1 into T2. What you will have? Just multiply these two things. U minus under root U square minus 2GH by G into U plus under root U square minus 2GH by G. It's like A minus B into A plus B, A square minus B square. So U square minus square of this one will be what? Root gets cancelled. You will have U square of minus 2GH G into G, G square. And if you multiply this minus sign into the bracket, what happens? U square minus U square gets cancelled, minus into minus plus. You will have finally 2GH by G square, GG gets cancelled, so 2H by G. So T1 into T2 is equal to what? 2H by G. So from this, you can write expression for H, height at which this point P is located. Okay, that H can be written as half G into T1, T2. So this is one important conclusion corresponding to this situation. Now I will go with the sum of these two roots. Considering, see what I am doing is, here I have two equations for T1 and T2. Okay, I am trying to explore rest of the points connected with this situation. What is this H? What is this value of U in terms of T1 and T2? Okay, since when the body is crossing this point P, how much will be the velocity possessed by the body? What is the maximum height to which this body reaches if it is projected with a velocity U? So all these details we can express in terms of T1 and T2. Because children, here whenever such kind of questions are given in the examination, the data will be in terms of T1 and T2. So whatever point finally he will be asking, whether it is about initial velocity of projection, whether it is about maximum height attained, or it is about height at which this point P is located, all these things you are supposed to express in the given data, in terms of given data. What will be the given data in such kind of situations? T1 and T2 values will be given. Okay, so that's why I am trying to express all the points in terms of T1 and T2. Height at which the point is located can be expressed as half G into T1, T2, isn't it? Now I'll consider some of the roots. T1 plus T2. If I add these two things, see, I'm going to add, this expression can be written as U by G minus under root U square minus 2GH by G plus, similarly this equation can also be written as U by G plus sign is there, see, under root U square minus 2GH by G. These two terms gets cancelled, minus under root U square minus 2GH by G plus under root U square minus 2GH by G. These two terms gets cancelled, U by G plus U by G, 2U by G. So sum of the two roots, sum of these two times T1 plus T2 is equal to what? 2U by G. From this equation you can write expression for initial velocity of projection in terms of T1 and T2, isn't it? See, U is equal to 1 by 2 G of T1 plus T2. Okay, so this is another important equation connected with this one. If initial velocity is known to us, can't we find the maximum velocity, maximum height up to which the body reaches? Yes, of course we can find. At maximum height, remember children, the final velocity is 0. Okay, since v square minus u square is equal to 2g, since we are dealing with the upward projection, minus 2g h maximum. Here at maximum height, final velocity will be 0. Therefore, what you will have? Minus u square is equal to minus 2g h maximum. Okay, minus minus gets cancelled. Then what you will have for h maximum? H maximum is equal to u square by 2g. What is u? Half into g into t1 plus t2. So let me replace u with this term. H maximum is equal to u square of this one, g square t1 plus t2 whole square by 4, t1 plus t2 whole square by 4. So u square is replaced by, what do you have? 2g. So g gets cancelled. So finally this is what you will be having, g by 4 2s are 8 t1 plus t2 whole square. So this is maximum height attained by the body in terms of t1 and t2. Okay, so the other thing is, when the body is crossing this point P in the upward direction, let the velocity be v1. Okay, let the velocity be v1. Let me try to find out that velocity equation in terms of t1 and t2. Since v1 is equal to, how it can be written? U minus gt. What is the time taken by the body to reach from point O to P? T1. Okay. So what is the expression for u? Already we have derived half into g of t1 plus t2. So half into g of t1 plus t2 minus gt1. You can take out g common, then what you will have? t1 plus t2 by 2 minus t1, g of t1 plus t2 minus 2t1 by 2. What you will have? t1 minus 2t1 minus t1. So g of t2 minus t1 by 2. This is what? v1. Velocity with which the body is crossing this point P. Even in the downward motion also, when it has gone to the maximum height and when, during its return journey also, it crosses with the same velocity. We have already discussed about this one. Whenever a body is projected with some velocity u, after reaching this initial position, again it will have the same velocity with which it is projected. Somewhere in between, if you consider one point P, while going upwards with whatever velocity the body crosses that point P, during return journey also it crosses the point with the same velocity, except directions are opposite, but magnitudes will be same. Okay, so these are the important points connected with this situation. Okay, so here in this situation, T1 and T2 data were given. T1 is what? Time taken by the body to reach from point O to P. T2 is what? Time taken by the body to reach from point O to maximum height and to reach this point P again. Okay, so let us continue with one more model. Now I will describe one more situation. Let us say from the ground, two bodies are projected. First, one body is projected with an initial velocity u1. After t seconds of time, after t seconds, second body is projected with what velocity? Let us say with a velocity equal to u2. With a velocity equal to u2. So when first body is projected with a velocity u1, it's going in the upward direction. After a time equal to t seconds, the second body is projected. Whether the second body crosses the first body or the first body goes to the maximum height and it comes, it will be in the return journey and it meets with the second body. All these things depends upon velocities of these two bodies. If at all u2 is greater than u1, for example, first body is projected with a velocity u1, it's going up. Second body, it was not projected yet. After some time it is projected. If you want this second body to meet with the first body during upward motion, you have to project second body with more velocity, because there is a time lagging, isn't it? After you are not simultaneously projecting the bodies. First body is projected with a velocity u1, And if you want the second body which is being projected after a time equal to t to meet with the first body, what you have to do? Definitely the second body's velocity must be higher than first body's velocity. Then it goes and somewhere it meets with the first body, isn't it? So I'll try to find out after what time the first body meets with the second body, under what condition? Let u2 is greater than u1. u2 is greater than u1 in the sense u1 is, the first body is going in upward direction. After t seconds the second body is projected, but second body is projected with more velocity. So now somewhere here it meets, isn't it? So I'll assume that let after a time t1 the first body, this is the first body, this is the second body. Okay, the first body meets with second body. Okay, so during this time t1, what will be the distance traveled by the first body? Let us find out that. I'll assume distance traveled by the first body as h1. h1 is equal to, how it can be written? u1, how much is the time of journey for the first body? t1 minus half g t1 square, minus sign is taken because it is upward projection, isn't it? And for the second body, let us say how much height it will cover. I am talking about meeting of both the bodies. Second body will also cover the same height. Second body also covers the same height, h1, isn't it? But the time is different. Second body is projected after t seconds of time, isn't it? And how much time the first body has traveled? First body has traveled for a time equal to t1 seconds. Okay, and second body has met with this one after it is being projected, with a time lag of t seconds. So what will be the time of journey for the second body? u2 into t1 minus t. Let me repeat this point again. First body is projected with a velocity u1. Second body is projected after a time equal to t seconds. If first body is having a time of journey equal to t1, then what will be the time of journey of the second body? It will be t1 minus t. t1 minus t. So u2 into t1 minus t minus half g t1 minus t whole square. And both are, they have reached the same height, because I am talking about what condition? Both are meeting after a time equal to t1. If they are meeting, it means both have reached same height. So h1, h1, LHS are equal. Now you can equate these two things and you can find out what this t1 is, isn't it? Let me equate. So u1 t1 minus half g t1 square is equal to u2 into t1 minus t minus half g t1 minus t whole square. Let me simplify this. u1 t1 minus half g t1 square is equal to u2 t1 minus u2t minus half g. Let me expand this. A minus b whole square, isn't it? t1 square plus t square will come. So, but minus into plus, it becomes minus half g t square minus 2 t1 t2 will come, minus 2, minus into minus plus 2, and this 2 gets cancelled. You will have g t1 into t, isn't it? Now see, these two terms gets cancelled, minus half gt1 square minus half gt1 square. So let me bring all the terms having t1 towards LHS side or RHS side. You can do anything. So I'll take towards RHS side, all terms having t1. Okay, and rest of the terms, what minus u2 et, and what else you have? Minus half gt square. I will bring them towards LHS side. Half gt square, this term, and next plus u2 into t is equal to, okay, u2 into t1, take this one towards RHS side, minus u1 t1, and what else we are left with? Plus g t1 tt, g1 t1 t plus g t1 t. Right. From here you can take out t1 common. What you will have? u2 minus u1 plus gt and here half gt square plus u2t, and from here you can write t1 as half gt square plus u2t by u2 minus u1 plus gt. So this is the time after which the first body meets with the second body. Okay, so this is one conclusion. Now I'll assume that if u1 is equal to u2, let us think about this one. What was the previous situation? Body is projected vertically in the upward direction with a velocity u1. After a time t, second body is projected with a velocity u2. If you expect these two bodies to meet in the upward motion, in the upward direction, when they are moving in the upward direction, if they are supposed to meet, what is the expected condition? The second body's velocity must be more, so that it goes and quickly it meets with the first body. If at all, if both are projected with the same velocity, with the same time lag, first this body is projected with a velocity u1, it is going up. Second body, after a time gap of t, it is also projected. So during upward motion, never and ever these two bodies will meet. This first body will go to certain height, and when it is falling back, then the second body will meet with the first body. This is what is going to happen. So here, if u1 is equal to u2 is equal to u, okay, let us find out after what time first body meets. See here in this case, how the first body is meeting with the second body? It's going up, and during return journey, it is meeting with the second body. This is first body and this is second body. Okay, because both are having same velocities. In the previous case, it is not like that. In the previous case, when it is projected with a velocity u1, it is going in the upward direction. After a time t, though the second body is projected after a time t, since it is projected with more velocity, during upward journey only, both have met at some height, isn't it? So in this case, let me substitute here. If I replace t1 is equal to u2, here u2 minus u1 both gets cancelled because both are same. So half gt square plus u2 can be replaced with ut by gt. You can take out t common, then what you will have? Half gt plus u by g, or simply what you can write, t by 2 plus u by g. So this is the time after which the first body meets with the second body. First body has gone here to the maximum height and it has come back, and this is the point somewhere here. It is meeting with the second body. Second body is like this, it is coming, and both are meeting here. Okay, try to understand here this equation. Whatever this u by g is there, it is familiar to us, already we have seen. If a body is projected with the velocity u in the upward direction, what is the time of ascent? Time of ascent is equal to u by g. It means the first body has gone up to here to the maximum height in a time equal to u by g, and from here to here it has taken a time equal to t by 2. T by 2. Now if the question is, after what time the second body meets with the first body, what is this equation? After what time, whatever this t1 is there, that is the time after which first body meets with the second body. If the question is about meeting of second body with the first body, second body with the first body, then the equation will be like this. Therefore, the time after which the second body meets with first body, that is equal to what? Time of journey of the body from this point to this point. Okay, how much it will be? See, second body is projected after a time equal to what? With a time lag of t, isn't it? When the first body is projected, second body is projected after t seconds. So if you wanted to talk about the time after which the second body meets with the first body, what you can do? I will take it as t2, and it will be how much? T1 minus t. T1 minus t. So t1 is how much? T by 2 plus u by g minus t. T by 2 minus t is what? Minus t by 2. So you can write u by g minus t by 2. So this is the time after which second body meets with the first body. This is the time after which first body meets with the second body. It's a bit tricky. Try to understand the situation. Okay. So this is one kind of model. Okay. The next session will discuss about tower model, and we'll try to solve some problems. Okay. Thank you, students.